This is Sahaana Das, and here I am to talk about such an elephant in the room that nobody wants to talk about: suicide. Do you know that every year close to 800,000 people take their own life, and there are many more people who want to attempt suicide? Also, every suicide is a tragedy that affects families, communities, and entire countries and has long lasting effects on the people left behind. Suicide occurs throughout the lifespan and was the second leading cause of death among 15 to 29-year-olds globally in 2016. It is a notable fact that suicide does not just occur in high income countries but is a global phenomenon in all regions of the world. In fact, over 79% of global suicides occur in low and middle income countries in 2016. Obviously, you all must be wondering that why am I giving you all these suicide facts and figures? So let me tell you, these statistics are going to be a base for me to explain you a blog I have recently written about. The blog is about studying suicide rates from 1985 to 2016 and using various machine learning algorithms to predict the future rates given a certain group of factors. So, after giving you a brief introduction on what I attempted to do, let's jump into the technical part. So, machine learning. Machine learning is a buzzword these days. So, what exactly is machine learning? To define machine learning in very simple terms, it is the science of getting machines to learn and act in a similar way to humans while also autonomously learning from real world interactions and sets of teaching data that we feed them. So, it's not exactly an accurate way to predict human action using machines like suicide and other factors, but definitely going through facts and figures, there is a certain pattern to which we humans, who are said to be very unpredictable, do react. I've briefed you about machine learning. Let's just scroll down and see what data set we have used in this prediction. So I have picked up a data set from Kaggle that gives us an overview of the rates from 1985 or 65, the years keep jumping, to 2016. It's a CSV file that contains columns like country, year, sex of the victim, age of the victim, number of suicide in that category of people, the total population of the country, and the rate that is defined for us in suicide per 100k population, also country year, HDI for the year, GDP per year, and let's see, GDP per capita. So just to explain you why we have considered both these factors, that is GDP per year and GDP per capita, is because there are certain countries that we found that have immense amount of wealth, that is the GDP per year is quite high, but the wealth is not equally, or let's just say uniformly distributed among the population. So we are going to consider both these factors. And then generation, of course, yeah. So what do we mean by generation? Generation, we mean the generation X, the silent, the millennials, and all of those. Yes, there is something called a generation gap where people tend to think differently. So it's not surprising that we have picked this up as a factor to decide a pattern for the suicides. Before exactly jumping into the core and loading the dataset, obviously we first have to import the necessary libraries. The libraries I have used are NumPy. NumPy is very popularly used for scientific computing. Matplotlib as the name evidently suggests, it's used for plotting 2D graphics. And Pandas, oh, it's a very popular library used for data analysis. Next, let's load the dataset. Here's the way we have read the CSV file, allotted our X and Y values. So like you can see, the assignment of X and Y values respectively. In X, we have dropped the fields that we do not find relevant or necessary. And then Y, that is a way we have found out to predict the suicide rates, that suicides divided by 100k of the population. That is how we define the rate of the suicide. So we are going to use supervised learning. So Just to brief about it, supervised learning is a machine learning task of learning, a function that maps an input to an output based on example of input-output pairs. It infers a function from label training data consisting of training examples. Hope that gives us a little bit of idea of what exactly supervised learning does. So, one big question that comes is what influences the determination of factors in prediction? So we have used correlation. So why exactly are we investigating correlation? Let me tell you, it is very important to discover and quantify the degree to which variables in your dataset are dependent upon each other. This knowledge can help us better prepare our data to meet the expectation of machine learning algorithms. For example, like linear regression, whose performance will degrade quite quantitatively with the presence of these interdependencies. So, just to investigate the correlation, I have plotted this correlation heat map. So, going through it, we observe that no two variables are quite linearly dependent. You see this? We have used seaborn as a function to find out correlation, and this is the code that's going to help you do that. Also, we have taken up factors that are going to be involved in scatter plots. Do you see this? We have plotted it using matplotlib. I'm going a little slow for you guys to sink in the plotting data and why exactly we are using the scatter plots to determine the relationship. Okay, so this is a scatter plot for GDP per capita and GDP per year. So, like I explained before, do you remember I was telling you that we are going to consider both of these because in some countries, like I have mentioned here, like Soviet Union, which has a high GDP per capita but did not distribute the wealth. Let's go around and see what else. It's going to be population and GDP per year. This is something again plotted to give you a flavor of how exactly the variables are connected to each other. Oh, and this is GDP per capita and HDI. It gives quite a function, right? Okay, so the next important thing before we go ahead is checking for outlier. So before we go ahead and check for outliers, let me just give you a brief description of what outlier detection is. Let me put it this way. Outlier detection is the identification of rare items, events, or observations which raise suspicions but differ significantly from majority of data. So let me scroll down for you to see for yourself. So we have plotted the GDP for the year of the country right here. So look for yourself. Do you see how the data behaves after 125? It's not clustered up or it's not in a very consistent pattern. It just moves. So if this is so confusing for the human eye, let us just imagine how our machine is going to react to it. It's going to give us a big hard time. So things that give us a hard time, let's drop them. So this is the code and we have dropped the data above 125. Okay, so after checking for outliers, I think it's time for data pre-processing. Before actually going through what is data pre-processing, let me tell you, data pre-processing is a very integral step in machine learning as the quality of data and the useful information that can be derived from it directly affects the ability of our model to learn. Therefore, it's very important for us to pre-process our data before feeding it to the model. So just a brief description, the concepts that can be seen here is handling null data, standardization, missing data, noisy data, discretization, lots of them. So let's just scroll down and see what exactly we have done in our pre-processing. So in the data set, when it mentioned GDP for the year, it gave us in a normal human format separated by commas, but our machine does not require that. We just need the float format, so here we have replaced the comma. without anything. So it's just like the commas are removed. Next, after extracting the numeric features and categorical features, we have put them in a pipeline to fill in the missing data with the mean of the values, scale, normalize the data, and encode the data with one core encoding. So this is the code for it. Do you see we have used sklearn for the column transformation and sklearn pipeline. And what exactly is pipeline? Um, Here's something for you. A machine learning pipeline is used to help automate machine learning workflows. So instead of individually picking up things and again encoding them or normalizing them, you put it in a pipeline. It's literally the meaning that it says. So let's just scroll down and see. Scale in first, one core encoder. This is the code. Just refer for yourself, and maybe I can give you a little insight on what these are. Let's start with scaling data. So feature scaling or standardization is a step of data preprocessing which is applied to independent variables or features of the data. So what it does, it basically helps to normalize the data within a particular range. So it's not just bizarre with one value being 62 and the other 10,000 something. It's going to give your machine a really hard time. Everything's going to go haywire. So what we do is we normalize the data into a particular range, and also if you think about it in a different way, it helps speed up the calculations in an algorithm. So now that I've told you what scaling and normalization is, let me give you a brief insight about what one hot encoding is. So let's just put it this way: one core encoding is a process by which categorical variables are converted into a form that could be provided to ML algorithms to do a better job in prediction. So in layman terms, you have Monday, Tuesday, Wednesday, and maybe I can put it as 0, 1, 2. So instead of your machine to understand it in Monday, Tuesday, Wednesday, because the machine does not know what Monday, Tuesday, and Wednesday are. We know it, they're days of the week, but the machine does not have to know. But it does understand what 0, 1, 2 are because it knows the binary forms of it. That is what one hot encoding does. It's a funny name. I don't know why they call it that, but it's a very important feature. So let's go down. After we have pre-processed the dataset, the next obvious step is splitting the dataset. As we work with the datasets, a machine learning algorithm obviously needs us to split the dataset between training and testing stages. So in this particular problem, I have used a 80-20% ratio. That is an 80% for the training stages and 20% for the testing stages. Okay, now let's finally jump into the algorithms. First one is trying linear regression. Linear regression, like I have mentioned, performs the task to predict a dependent variable y based on an independent variable x. So our dependent variable here is the suicide rate, that is suicides number divided by 100k of the population, and x are the other factors. So this is the code. We have used sklearn linear model. You import the libraries, import linear regression, and put it on training. So how do we evaluate how good our model has performed? So we have so many metrics, different kinds like mean square error, root mean square error, R square, chi-square, so many of them. So we have used the root mean square error for our model, which measures the difference between the value predicted by a model and the value actually observed. So here in the code we have imported sklearn metrics, and from there we have imported the mean square error and then taken the square root of it. So root mean square error. So yeah, for the linear regression we find the RMSE value for the test set to be 12.48 something. This is the value. So like the name suggests, root mean square error. You see error, so obviously the less the error, the better the performance. So let's just see how good or bad this 12 point something is. Next, let's compare. The next algorithm that we have in place is support vector regression. So before jumping into it, let us just see what a support vector machine is. Support vector machine is a linear model for classification and regression problems. It can solve linear and nonlinear problems and is useful for most of the practical problems, and suicide rate detection, or rather prediction, is one of them. So, what exactly is the idea of SVM? This algorithm creates a line or a hyperplane which separates the data into classes. So, let's just see how the code works. From sklearn, we have imported the SVM, and then we import the module of SVR, the support vector regression. And in the regressor, we define the kernel, and then we fit it with X train and Y train. X and Y have been defined before, and then we run it. So how exactly are we going to evaluate this? The same thing, we use the RMSE values, and we have calculated the RMSE values as we have done for the linear regression. Let's just look at the values. The RMSE values for the test set comes around 15.4, that is higher than the linear regression one. So if we compare both of these, that is the linear regression and support vector regression, evidently linear regression has an upper hand. But nevertheless, we have more algorithms to compare with, and let's just see them. Next comes the decision tree regression. And decision tree is quite a popular algorithm because of its simplicity and output that it gives. So how exactly does it work? Decision tree builds regression of classification models in form of a tree structure. Obviously, decision tree, you see there. Also, it breaks down a dataset into smaller and smaller subsets, while at the same time, an associated decision tree is incrementally developed. So it just goes growing. Um, in contrast to a regular tree, a tree has its roots down, the ones that you see outside, but this decision tree has its root right at the top. And the final result is a tree with decision nodes and leaf nodes. A decision node has two or more branches, each representing value for the attribute tested. Leaf node represents a decision on the numerical target. And you see here in this decision tree regression map that we have, it's trying to line itself with a sine function. You see? So there are lots of things we can discuss about decision tree, but let's just see how we have deployed the code here. So here's the code. From sklearn, we have imported the decision tree regressor, allotted the same regressor fit with X train and Y train, and put it on training. So again, let's come to the evaluation part. We have created the same factor here, the RMSE value, and the RMSE value for the test set is 7.39. So this is much lesser than both of the values that we have considered, or rather calculated previously, that is of the linear regression and the support vector regression. So till now, between the linear regression, support vector regression, and decision tree regression, the decision tree regression wins hands down with the least error of 7.39. Okay, so let's go down to our fourth algorithm, that is the random forest regression. So why do we have to use random forest regression when we have had decision tree regression? What's the difference? So there's a problem with decision trees. Decision trees are sensitive to the specific data on which they're trained. If the training data is changed, the resultant decision tree can be quite different, and in turn the predictions can be quite different. So the problem of overfitting occurs and is always present with the decision tree, if not always, most of the time. So to address this weakness, we turn to random forest, which illustrates the power of combining many decision trees into one model. So what exactly is a random forest? Random forest is a supervised learning technique which uses ensemble learning method for classification and regression. Ensemble because we're using many decision trees to train the same model. So jumping into the code. Here from the sklearn ensemble, we have imported the random forest regressor, and here the regressor, we have used the random forest regressor, and the number of estimators is 30. Before that, before exactly telling you what estimators is, let's just see the rest. The same regressor fit that we have used is X train and Y train, like the previous models. So now that we have seen the X and Y train, the regular format of the code, let me just go back to the n estimators. Um, can all of you take a guess what these n estimators are? Just jump back to the definition of random forest regression. The number of decision trees. Obviously, the n estimators are the number of decision trees that are going to be used in this random forest regression. So n estimators are that. The number of decision tree classifiers or regressors on various subsamples of the dataset and uses the averaging technique to form the final output. So that is what is n estimators, and the rest of the code like I've explained before. Okay, now let's come to the performance evaluation. The same are the huge difference between the RMSE value of the random forest regressor and the support vector regressor. The support vector regressor gave us a value of around what, 15 point odd something. This gives us 5.625. So if you compare the results by the different algorithms, just take a look. Hands down, the winner is this, the random forest regressor with 30 estimators. We can keep changing the number of estimators and look for a value, but then the things I have done, it tends to overfit. I have gone with 50, 60, and 100, and things go and overfit the data. Something that is not recommendable or something that we require. We won't need a overfit in random forest model, obviously, right? Because that's why we pushed away the decision tree. So let's just scroll down and see the scope of improvisation. Uh-oh. Yeah. So the accuracy of the model of linear regression can be improved quite to a level by backward elimination. So let's just read what it says. It's a stepwise regression approach that brings, or rather begins, with a full saturated model, and at each step gradually eliminates variables from the regression model to find a reduced model that best explains the data. So removing or rather eliminating variables implies that it eliminates irrelevant, or let's just say lesser relevant variables, to give a more streamlined approach for the linear regressor model. So this is the code. You can just go through it and see how it works for you. So concluding the video, the conclusion here is the blog was aimed at explaining how technology can be used in addressing the elephant in the room, that is suicide. And I'm not saying that this is something we can do to completely stop suicide, because that involves you to step out of your room and your comfort shoes and help somebody who's probably looking out for help or not looking out for help. But it's up to you to reach out and see the people around you and their mental health, and obviously first your mental health before physical health. Let's just promise ourselves that we are going to have a good mental health and not give up in life. So hopefully it was a successful attempt on my part to do my very small bit in using the process and academic technologies that I'm learning to deploy them into real life, or rather problems that affect me and I find them very depressing or sad, or something that requires addressing. So thank you for your time, and I hope that I helped you with my little bit of explaining or the code. You may go through my blog. I am going to be putting up the link in the description. Tell me how you like it with the comments below. Thank you so much.